Yes, good afternoon and welcome once again to our Maniac talk today. Today we have a very special guest. Let's give him a round of applause to welcome to Bill Clark. Of course, as some of you know, or all of you know, of course know, Michael Freilich is the director of Earth Science Division at NASA headquarters. Like a movie director, he guides the division's technical crew and actors to ensure that the division fulfills its mandates and purpose. And that is, of course, we all know this, it's advance our scientific understanding of Earth as a system and its response to natural and human-induced changes, and to improve our ability to predict weather, climate, and natural hazards. The work done in his division has opened our eyes wider to see amazing wonders of how our planet functions. But today, he's not going to talk about that. Today, he's going to talk about his own journey, and share some wisdom gathered over the years, especially with the colleagues who are just starting out. In fact, his title captures this very well. From beaches to bureaucracy, evolution of a career. Okay? So, how did he get there? So, we are all interested to hear that. What steps did he have to take to get there? How did he get involved in what he's doing now? What excites him about it? Ladies and gentlemen, help me welcome our speaker, Michael Freilich.
Wow, just like in the title, it's going to be all downhill from here, I'm afraid. So thanks very much for, taking time out of your lunch break or writing the next paper or whatever it is that you would have been doing to come and listen to this. I'm hoping that it'll at least be fun, if not necessarily informative or useful. It's kind of daunting to give a talk like this because, you know, when I thought about it in the past for other people, you're kind of asked to give this talk as you enter your dotage. And I kind of feel like I got at least a few more weeks to go. It is sort of like the joke of the grandfather and the young grandchild giving a talk like this. You know, the grandchild says, Grandpa, what did you do when you worked for NASA? And tears come to the old man's eyes. And he says, I've been waiting years for you to ask that question. Here, sit on my lap. First view graph, please. So, anyway, the somewhat irreverent, but hopefully, well, unfortunately accurate title, as we've heard, is From Beaches to Bureaucracy, the Evolution or possibly the Devolution of what I would like to call a career. It may or may not be. So the beaches are there. The bureaucracy is here. Those with good eyes recognize that it's Landsat 9. And here's about what we're going to be talking about. I'll do the sort of obligatory scanned pictures of forebears. That seems to be the way these things start. Talk a little bit about the epiphany that I had actually in high school. We'll talk about doing science while learning about science, and then talk about learning about life, not to mention science, while doing it and getting paid for it. And then we'll go to the last couple of years, 11 to be exact, at NASA headquarters, where it's not obvious that anything got done, at least at my desk. And we'll talk about what that symbol means there if people here don't know. And then, of course, we get to the geriatric blatherings, which I call insights and gems. Okay. So the obligatory scanned photos of forebears here. In these charts here, these images, this is my maternal grandfather and my maternal grandmother in about 1924 to 26, something like that. Pretty good looking. Clearly the genes got diluted by the time it got to me. And here they are in 1937, just a couple of years later, with my mom. And the thing you see here is actually that both of these images and many, many others that I looked at for this talk were taken on beaches. Okay, happens to be Atlantic City or Ventnor in New Jersey. And so I probably come by the beaches thing honestly. I'll also point out, although my mom probably wouldn't like this, it's not the only thing she's not going to like about this talk. This is probably taken about 2 years before she met my dad, who was a similar age. And then they got married. This was 37. They got married in 1950. And he passed away in 2002, early 2002, and they were married the whole time. And that, you know, I don't want to call it a nuclear family. We were waiting to explode at any time, but no, but that was really a very important part of my upbringing. Okay, the epiphany. Okay, we'll start basically with high school, because that's where I actually figured out what I was going to do in life, or at least for the first part of life. And you know, people talk about their careers, and you think that the career probably looked like this, but they talk about it like it was that. Actually, I think that from a scientific standpoint, mine is more like the long road. Okay, it had its ups and its downs, and there's a curve someplace down the road, but it was actually pretty straightforward for me through the career. And it started out, as I said, in high school. I grew up in a place called Havertown, a western suburb of Philadelphia. Actually, we were in Ardmore, but it was Haverford Township. Went to public school, elementary school, junior high school. This is Haverford High School. It looked the same then as it looks now, which may say something about the tax base. It's unclear. And also, as you'll see, I went to Haverford College, and I couldn't shake the name for like 21 years. But in high school, I joined the Oceanography Club. It was started by Joe Elliott, who was a shop teacher and an avid scuba diver. And so, you know, we're talking about whatever it was, 67 to 71 or something like that. So he was a scuba diver. He about a year before, maybe my freshman year or so. Actually, I was only there 3 years. He started the Oceanography Club, and his partner in crime was Robert Bennett, who was a physics teacher by trade, although his actual passion was to be a party boat captain for fishing boats. No, I'm real serious about this. And Bennett had designed and built his own fishing boat, which he docked in Cape May. And that's what he really lived to do. And it was clear in his physics lectures as well as on his boat. And together, the two of them said, we're going to have an oceanography club, and like 4 of us showed up or something. And on Saturdays, several Saturdays during the year, we'd go out on Bennett's boat and lower Secchi discs, you know, to see how clear the water was, and fish, so that then he could go back to the dock and show the fish that we had caught, actually in nets, but he omitted that part of it, and then get more people to come onto his boat, actually paying customers. And then the rest of the time, we sort of sat around designing boats and trying to learn a little bit about oceanography. You know, ocean, it's big, islands are in the middle of it, surrounded by water, all of that sort of stuff. But I remember really clearly, I don't exactly remember which year it was, whether it was my junior year or senior year in college, or in high school. But we were out on the boat, and then I went out onto the beach, and I was sitting on the beach and looking around, and I got this epiphany. I wanted to know, why do the waves keep folding over? Okay? All of a sudden, it was an incredibly fascinating thing to me. Why is it that waves, which are basically sinusoidal out in relatively deep water, when they approach the beach on shallow water, you know, they don't get peaky, they get asymmetric with steep forefaces and long sloping aft faces? And what exactly was causing that? And how would that move the sand around? Okay, that came to me in high school. That's what I wanted to do. That's what I wrote my thesis on, and it in fact hadn't been solved. After my thesis, we like to think that it was solved. And so that's pretty much a straight course. Okay, it took me through a whole long portion of my career. And by the way, this circus cartoon didn't come out until August of 1989, okay, which was thankfully after I had finished my graduate work and gotten my degree, although there were people who weren't sure I would actually make it by that time. But I got about 85 copies of it from friends and everything like that when it came out nationally here. Okay, so let's see. What else did I want to say? No, nothing more that I wanted to say on this. Okay, so now we're finally out of high school. I want to be an oceanographer. I want to be a near-shore oceanographer. I want to look at shoaling surface gravity waves. I want to figure out what's going on, how it is that the waves are changing and they're moving sand around, and I basically don't know a thing other than that. Okay? So it was clear that if I wanted to be a scientist, of which I had sort of vague ideas, that I was going to have to learn a whole bunch. I also, by the way, as did my parents, wanted to be in college, okay, because I graduated high school in 1971, and there was a war going on, and people were being drafted, and I didn't have bone spurs, and like it was a bit of an existential problem, so there was motivation. I wanted to learn what science was all about. I also wanted to go to college. Our house, which is the house my mom still lives in, is less than 3 miles away from the Haverford College campus, if anybody knows that area around western suburbs of Philadelphia, the main line. So I had been around Haverford for my entire life. I applied to like 4 schools, Drexel, Penn. I didn't realize somebody else was going to Penn about the same time, much older than I was. Haverford and Swarthmore, and I really wanted to go to a small liberal arts college, just in case this science thing didn't work out. But I also wanted to go someplace where if the science thing did work out, I could participate as a student, as an undergraduate student, and participate in some meaningful way. At this time, and so decided to go to Haverford. My dad's father wanted me to go to Swarthmore, but Haverford won out. Haverford at that point was like 720 students total, all undergraduates. We had about an 11-to-1 faculty, student to faculty ratio. The vast majority of faculty lived on or near the campus. It was a Quaker school, still is, run according to an honor code. Everything about it according to the honor code. It was the most amazing experience. And I double majored in physics and chemistry. Why did I double major in physics and chemistry? I knew that physics was sort of where I wanted to go. But if I didn't double major in something, and it might as well be a science, then I'd have to follow these distribution requirements, like, you know, take a bunch of humanities courses and social sciences. But if you double majored, they say, oh, well, he's double majoring. He can just take the courses that he wants. But even so, I got a little bit of a rounded education, as hopefully you will see coming through here. So one of the things that I did pretty early on at Haverford was start hanging around the science building called Stokes Hall. It was brand new then. It's being remodeled or even demolished now, which is sobering. I hung around it with just a couple of other people. I mean, it's not like I was going out on dates or anything like that. So might as well hang around the science building. I eventually got keys to the science building. That was great. I could spend a lot of time there. Then got keys to the library in the science building, and this was like seventh heaven, okay? Don't have anything to do? Fine, go up to the science library and look at journals, read books, while away the time. And you can understand why I didn't get too many dates. The end of my freshman year, beginning of my sophomore year, I met a professor who was young at the time. He was older there. We didn't have no laptops in 1971 or 72. We can talk about the computing systems we did have. Met a young professor who had just joined the faculty at Haverford, and his name was Jerry Gallup. Jerry had actually just gotten his degree in 71, his doctorate from Harvard in condensed matter physics, and he was doing a lot of supercooled, superfluid, superconducting helium experiments and everything like that. But he was wanting to branch out a little bit. Let me say a few words about Jerry. He went on to be one of the first and one of the few physics researchers who's been elected to the National Academy from a small liberal arts college, which is basically, Haverford is where Jerry has spent almost his entire career. He'd take a sabbatical here and there. For a while, he dabbled in thinking that he might want to be at the University of Pennsylvania, but saw the light and came back to Haverford. So he's had quite a remarkable career. So he was elected to the Academy in '93. He's been the key author on many Academy reports. He's deeply involved in Academy governance right now, and has gotten honors all over the place. I think he's actually featured in Gleek's book, perhaps Genius or something like that, where they talk about it. So pardon me? Chaos? Chaos? Okay, right, chaos, you're right. So Jerry asked me whether I wanted to be his first undergrad, and there were no graduate students there, so it's sort of the first of everything, first undergrad research guy. And sounded great to me until he said, go find a project, which we'll talk about in a second. And I was. And by the way, all of this research was done for no credit or anything like that. I read a bunch of papers and everything, and eventually together, and he had quite a bit of guidance in this, we decided that what we wanted to look at was what he wanted to look at, and therefore I wanted to look at, was instabilities in the Taylor instability in Couette flow. Okay, I'm not going to give you a lecture on Couette flow. I've forgotten everything that we've done decades and decades ago. But basically, this is flow between rotating cylinders. And in our case, we had an inner rotating cylinder and an outer stationary glass cylinder with fluid in between. And if you rotate at relatively low velocities, everything is cool. And, you know, it's sort of solidish body rotation, although the fluid has viscosity and everything, and therefore there's a no-slip condition on both the inner and the outer walls, which are going in different directions, or at different speeds, I should say. As you increase the driving force, a really interesting thing happens. The fluid has an instability, and it starts to acquire axial, up and down, and radial velocity. And so the fluid is not only going around the inner cylinder like this, but it's also like a bunch of donuts piled up around the inner cylinder. And Jerry was and remains fascinated by the transitions to turbulence from otherwise considerably less turbulent conditions. And that's what we looked at. So what I did was, to start out with, I learned how to machine, because I designed and built all of the wet part of the apparatus. You know, the inner cylinder, the outer, really well machined. I didn't do it, had a glass works do it. Outer cylinder, because you certainly don't want imperfections there. The seals, the motors that ran it very, very precisely, on and on and on. And we stuck this thing onto an optical bench that had a laser on it, and we basically built a laser velocimeter where the light goes in, you dope the fluid with tiny little latex balls that are neutrally stable, but they scatter the light. And you beat the incoming and outgoing light against a beam that's been split off from the laser that hasn't encountered any motion. And then with a photomultiplier tube, you basically look at the beats between them, because there's a Doppler shift from the scattered light based on the radial, or depending on where you're looking, the axial velocity. And so we could penetrate, for the first time, make direct measurements without some probe or anything like that at the fluid in the space between the cylinders. Okay, enough of the lecture. It resulted in actually a paper in Phys Rev Letters. The first paper that I had written and been an author on. We actually got a couple of more papers out of it before the end of my first year in graduate school. And it set Jerry off on his career. Not that his career wouldn't have been faster if he hadn't spent time with me, but he then worked with Harry Swinney and has become quite the savant of and guru of transitions to turbulence in many, many different ways. So I was feeling pretty good as a senior. Hey, man, I got a paper. We also did other things. A friend of mine, Dan Rabin, and I, he was also, well, since I lived like 3 miles from campus, less than 3 miles from campus, worked all summer long between my junior year and senior year on this project, and so I could work in the basement of Stokes all the time during the summer. Still didn't have any dates. Another friend of mine was also spending a little bit of time there. One summer, I think it was the summer before, we had this old natural uranium research reactor that a previous long-departed professor had set up at Haverford, and they decided to get rid of the uranium. So Dan Rabin and I did a little bit of reading and said, okay, we know how to do this. And with our hands, took the uranium out and put it into boxes and slapped radioactive stickers on it and everything, and called up a giant truck to come take it. Uranium is really dense and really, really heavy. And so hopefully we won't have to tell healthcare insurance all about that sort of stuff, because I doubt that we did a good job. But anyway, and I thought this paper was really cool. And I thought the fact that I had a paper was really cool. And I was really, really liking this science thing. A little bit of sobering happens when I talked to our son, who is a PhD in aerospace engineering. His undergraduate physics work at Amherst on Bose-Einstein condensates earned him a first author paper in Science, second author in Phys Rev Letters. Okay, well, you know. Maybe science wasn't so great in those days. I don't know. Okay, but, okay, so I really, really like this science stuff. I was convinced that I still wanted to know how the waves were modifying and why they were folding over. I was still convinced that I wanted to be an oceanographer, although I had no clue what oceanography really was. And I know that I knew that I needed to go to grad school to learn oceanography. And this is not my chart, by the way. I got this off of the web somewhere, because I would never say that Woods Hole was on Cape Cod. But literally, the way in which I figured out what grad school to go to was go to a science library. That's my second home. Read a whole bunch of recruiting stuff. Basically came to more or less the same conclusions that this person did, not quite. You know, Woods Hole, Scripps. I also applied to Oregon State. And you know, Woods Hole was famous. It was on the East Coast. Scripps and Oregon State were like, you know, in some different universe as far as I was concerned. And at this point, my parents, I think, were, well, let's say, apprehensive. Okay, because I'd been talking about oceanography, and they had been saying, yeah, he'll grow out of it eventually, maybe be a doctor, or certainly not a lawyer. And they started asking questions like, has there ever been a Jewish oceanographer? And they knew why they didn't know any Jewish oceanographers, for instance. Of course, if we had only known, okay, and this is one of these amazing stories, there were Jewish oceanographers. One of them was named Robert Freilich, okay, who started out as an acoustic oceanographer and a marine geologist, went on to an incredible government career, became Carter's administrator for NASA, okay, throughout the entire Carter administration. And Bob and I have talked, and he went to Woods Hole, went to GM, became director of ARPA at various times, all of this sort of stuff. He told me that his parents said exactly the same thing about the oceanography stuff. Okay, but the story gets better. Okay, my brother, my younger brother's best friend in college, and since then, is Matt Freilich, who turns out to be Robert Freilich's nephew. And Matt was my brother's best man at his wedding. So it's a pretty small world when you look at it. My parents also had other questions, like, how do you pronounce La Jala? And if you go to Oregon, like, don't they drive Conestoga wagons around there or something like that? It's kind of the end of the trail. So I got accepted to a bunch of these places. They all offered me money. Everything was cool. How do I decide which one? Okay? And it's pretty straightforward. In January of 1975, so our paper had just come out, I was delivering a paper alone at the American Physical Society meeting in Long Beach, California, which was halfway to that other universe. So I figured, okay, I'm there, I'm giving the paper, blah, blah, blah. I'll take a trip down to Scripps and check that school out. And I did. So it's the middle of January, puffy clouds. Talked to, you can hardly see it here, talked to a variety of professors, including Clint Wynett from the Shore Processes Lab, which was just at the base of the pier. I remember sitting in his office, looking out at the pier and the blue sky and the puffy clouds and the 78-degree weather and everything in January, and he's going, yeah, sorry, it's pretty stormy. We had a big wind yesterday, and the waves are crashing in. Okay, fine, so that was Scripps. Seems pretty good. Went to Woods Hole in March from Haverford. Like there's blizzard warnings. I am not making this up. Okay, there's blizzard warnings. I drive up. I have appointments to meet with a bunch of professors and everything like that. Henry Stommel is going to be giving, who I didn't know, obviously, is going to be giving a seminar that afternoon. Everything looks cool. I go up there and announced myself to the secretaries, and they said, ooh, it's supposed to snow really hard. And a lot of people aren't coming in today. And it sort of got worse from there. And then I drove out to my brother at Amherst. He was an undergraduate, a couple of years younger than I am. I drove behind a snowplow on the Mass Pike for pretty much the whole way. Okay, so you didn't have to be a genius to figure out which place you were going to. Scripps it was. Okay, and Scripps is a pretty nice place. For those who haven't been there, and La Jolla, or La Jolla, if you're my parents, is a very nice place. And I spent the next 7 years or so of my life in IGPP, the Institute for Geophysics and Planetary Physics, Walter Monk's place, and the Shore Processes Lab, Doug Inman's place, the home of coastal oceanography and nearshore oceanography down there. And basically, I was living the dream. A couple of days after graduating from Haverford, my brother and I got in a car and drove across the country. The day after arriving at Scripps, literally the day after arriving, I met a guy named Dudley Shelton and his wife. Dudley's an oceanographer. We'll talk more about it. We were out on a party on the pier. And for new students who were arriving, Dudley was 1 year ahead of me, and he's been a stalwart friend for, well, ever since then. So what is it, 32 years now, or 42 years now, or something like that, 42, I guess. And I was living the dream. And what is the dream? Well, I had had enough of an education at Haverford to be semi-literate, so, and by the way, almost all of these pictures are mine. I'll point out afterwards the ones that weren't, that I didn't take. But I knew Masefield's poems, Sea Fever. I must go down to the seas again, to the lonely sea and the sky, and all I ask is a tall ship and a star to steer her by, and the wheels kick, and the wind's song, and the white sail shaking, and a gray mist on the sea's face, and a gray dawn breaking. This is Oregon, by the way. Okay. I must go down to the seas again, for the call of the running tide is a wild call and a clear call that may not be denied. And all I ask is a windy day with the white clouds flying and the flung spray and the blown spume and the seagulls crying. That's not a seagull. That is. Okay? I mean, this is great. Why would anybody leave? So I immediately revised my timeline. 6-year minimum. Okay, we're going to learn everything there is to learn about waves and then see whether this is really what I want to do or something else. But first I started out actually working for Robert Stewart. For those who know oceanography, Robert Stewart's, this is Robert Stewart, the Lesser, he calls himself. And he eventually went to Texas A&M. But he was doing deep water waves, and he had a pitch and roll wave buoy. And I knew a little bit about Fourier analysis. And so we were doing good stuff until it came to time to actually go out on a ship to measure these waves with the pitch and roll wave buoy. And so the first ship that I went out on was a ship called the Acania, which is a river frigate that was owned by the Naval Postgraduate School. And so we were running up and down the coast of California. The waves are coming in this way. The Acania is about 2,000 feet long and 12 inches wide, with a wicked roll, as you might imagine. and this didn't work out real well. But I hung in there for another year. The next summer, we did a really interesting thing. We were going to be measuring waves with Chip Cox and his graduate student who were putting down long cables on the bottom off of Seattle to measure microseisms. I can do another lecture on microseisms, but I won't. That cruise also turned out to be a disaster, but it was a really interesting cruise because the year before, so this must be like 76 or so, the year before, the ice hadn't come out of the North Slope. So, they were building up the North Slope oil drilling and everything like that. So all of the companies were way behind. So what they did was they chartered every vessel in sight for the next year from Seattle to take supplies up and everything like that. Our original charter got blown away. So we took, John Wayne's boat called the Wild Goose, which was a converted yard minesweeper. And great boat, except for the fact that he had taken the fantail of the boat and put a whole second deck on, and it was all enclosed and everything like that. And we just cut that off. We did. Went to the boatyard, cut it off. We were desperate to get out. We were paying, and it was like the only boat around. We cut it off. We put an articulated crane on the stern. We went out. We ran a terrible experiment. I was sick the whole time. And then it came back and put it all back together again. And if you look up the Wild Goose on the web, it's now I think in Newport Beach, and you can get it. You can rent it. It was great. We had his crew and we had his food. Not bad. Okay, but it suddenly dawned on me, not suddenly, over this year, okay, this sea fever thing had a different aspect to it. Like perhaps from Boswell's Life of Johnson, and sorry for the sexism here, but no man will be a sailor who has contrivance enough to get himself into jail. For being in a ship is like being in a jail with the chance of being drowned. A man in jail generally has more room. This, by the way, is my niece, Mara Freilich. She's at Woods Hole right now studying in graduate school, studying oceanography, and that's her berth on the Kalmar Nickel. The middle one is her berth on the Kalmar Nickel. Okay, so a man in jail has more room, better food. This is from 1961. That's Roger Revelle up there. And this is Walter Monk, who's celebrating his 100th birthday this year. Still submits proposals. Still gets them accepted. I mean, you got to turn down a 100-year-old guy. I mean, come on. Okay. More room, better food, and commonly better company. That's Roger Revelle again, 20-some years earlier. This is a Scripps cruise back in the day of strong men and sailing ships, okay? And then there was this, okay? About a year after Johnson had made that quote, almost exactly a year, he had this other one. Men go to sea before they know the unhappiness of that way of life. And when they have come to know it, they cannot escape from it because it's then too late to choose another profession. This is indeed my license plate. My wife, Shoshana, first got me seasick in, that is the license plate, seasick in California, and then we moved to Oregon later on, and this is the Oregon plate. When we came to Virginia and Maryland, unfortunately, somebody else has that plate. Okay. Okay, so let's get back to what's going on. I still want to understand why the waves are folding over. I'm learning about waves, but I'm not learning about nearshore waves and beaches. So I went down to the Shore Processes Lab and ran into a young professor who had just graduated from Scripps and done a real quick postdoc and come back. He had graduated in 74. This was like 76 or 77. And his name was Bob Guza. known to everybody, including his wife, as Cousy. There's a number of things we hit it off in like the first 7 or 8 minutes that we were talking to each other. He was teaching a nonlinear waves course that I really liked and saw some ways to improve, which I would tell him. But these are pretty informative images of Cousy, none from that time. These are all from later. Let's start up in the upper left-hand corner. So that's Cousy, the one with the beard and his hands sort of like this. And you notice that he's not wearing shoes. Well, of course, he's on a beach, right? So why would you wear shoes on a beach? The trouble is that Cousy doesn't wear shoes like when he's crossing the street, doesn't wear shoes when he's giving a lecture, doesn't wear shoes any time. Okay, I think his sheets get black within the first 5 minutes of crawling into bed. But you'll never find a picture of Cousy in shoes. There is a classic picture that's out there. I couldn't find it for this talk, in which Cousy and I are both wearing ties, putting to lie the myth that we only had one tie between us, that we kept. Okay, look at that briefcase. He's on the beach, a field deployment. He's talking to Steve Elgar and Britt Robbenheimer, and he's got a briefcase. I mean, you can never tell when there might be time to do work. Okay? He always had a briefcase. I always have a briefcase. I don't know. Okay? Then look at Cousy here and here, actually in the ocean. Okay? You're never going to see him in the ocean farther in than that. Okay? Bob doesn't swim that well. In fact, hardly at all. And may not be the most comfortable guy in the water. Pretty interesting for a nearshore oceanographer. You also see that when you work with Cousy, you only have the highest technologies. Look at the tools he's got, or the tools that we let him use. Okay? I mean, you want to know where something is? You get a tape measure and you measure where the heck the thing is. You want to fix a current meter that maybe is a little over? You use the right tool, a sledgehammer. Okay? Cousy did everything. All of us did everything. I was his first student, okay, just like with Jerry Gallup. We just all did every job. Now, Cousy actually didn't do every job because there were a bunch that we wouldn't let him do. But here he is, blowing barnacles off of current meter pressure cases. And we just, and that plays into the story a little bit later on. And here's good. Cousy taught me one of the great tricks of working on beaches in Southern California, especially during the summer when there's lots of people around. We would put out all kinds of run-up meters and things like that. And people, of course, we'd have trucks and be dancing around in wetsuits and stuff, and people would be interested. What are you doing? And Cousy was the one who taught me to just say, look, I was just hired by the company that's putting in the nuclear power plant. I really don't know anything more. Okay, and there he was doing that. So we considered ourselves to sort of be ambassadors for science at the time. But working for Cousy was absolutely an unbelievable dream. Okay. Soon after I started working with him, he said, look, Mike, as long as you work your 60 hours a week, I don't care when. But there was plenty to do that took a lot more than 60 hours. And so I ended up doing everything. I learned how to dive. I learned how to do underwater construction. I did machining. I designed wave staff instruments. I ran our computer at the entire Shore Processes lab. Went from a 16-bit Perkin-Elmer computer with a 5 megabyte disk that was literally 5 megabytes. It was literally this size to the brave new world of a 32-bit. That was an interdata computer, a 32-bit Perkin-Elmer computer that had 250K of core memory. A computer that has core memory. When the power goes out, it just starts right up again. It doesn't lose anything, which is kind of interesting. And a whole variety of other tasks. And when the time came, and I designed a big field experiment, and we'll talk a little bit about that in a couple of minutes, When the time came to actually run the field experiment, because we didn't like have a grant. I don't believe Cousy ever had a grant for my work. Everybody in the lab helped because I helped everybody in the lab. And we'll get to that in some of the blatherings at the end. This is the cover of my thesis. That's me in the boat. Okay. Actually did flip a boat over at the end of the pier one time when a wave broke outside, confirming my mother's fears. But I basically had 3 really profound personal experiences at Scripps. And I'm going to present them to you in no order. Not a priority order, not a chronological order, so don't even try to analyze this, okay? So the first experience was I met Shoshana, my wife. After a couple of days, we got engaged. And we just celebrated our 36th wedding anniversary last week. So that was one. Okay. Second one was a conversation I had with my mom. This is my mom and my dad a couple of years before I was born, maybe 6 or 7 years before I was born. And we'll have more to say about my dad in a couple of minutes. I'm running long here, but sorry about that. But I had come back. Remember, I went to the West Coast. No Freilich had ever been to the West Coast before and lived to tell about it, let alone came back. And so I'd been away from home for like a year or 18 months. I don't remember when. I was all of 21 or 22 years old. I'm about to, having spent time with my parents, I'm about to go back the next morning to fly back to San Diego, La Jolla. And my mom and I are talking just before we each go into our beds. My dad was downstairs. And my mom says, well, you know, things look like they're working out pretty well. Don't do anything that I wouldn't do. 21 or 22 years old. Pulled myself up to my full height, and I said, Mom, I'm sure that at this stage in our lives, I've done a lot more than you had done when you were my age. And she didn't miss a beat. Okay? She just looked at me and said, I wouldn't bet on it. Okay? Like, no sleep that night. Okay? And I am certain that she's right. Now. Okay? I mean, like she had almost all of her kids by that time. All 3 of us. Okay. The third thing is experience is really profound. And I'm not going to give you a big lecture, except to say that on 10 June 77, I happen to remember the date because it's seared into my memory, some other people had 2 pressure sensors out in a cross-shore line. One was in 10 meters of water, one was in 5 meters of water. It was a very narrow band. This is a wave spectrum, okay, frequency on this axis, spectral density on that axis. Basically what you're looking at, and this is a different day, but the spectra look very similar. What you're looking at here is a day that's dominated by narrow-banded, long swell, 16-second swell or so, coming from halfway around the world, okay? And in 10 meters, the spectrum has this big peak and then not very much. And in 5 meters depth, you see this second harmonic peak pop up, okay? And my thesis and my work was basically threefold: to figure out why and how the waves were evolving. I did theoretical work and came up with a theory that has no adjustable parameters. You make a scaling argument at the beginning that weak nonlinearity and weak dispersion balance each other, and that bottom slope is smaller yet in the scaling. And you just drive the equations through to the end, and it turns out that that is exactly the physics that's going on. So I developed this theory, solved it numerically on these old clunky computers, because you've got hundreds or thousands of coupled differential rate equations that all have to be solved simultaneously. I used the best numerics that we had, and things would work. You know, model runs would take weeks on the computer, but I'd run in the background and not interfere with everybody else. Plus, it helped to be the system administrator for the computers. People sometimes said, why is my stuff running slowly? And I'd say, probably because you code badly. And ran this experiment. But I already had this data set, okay? And on my birthday, and I think that it was in 1979, maybe it was in 1980, but I don't think so. Again, it's my birthday. I don't have much going on. Go into the lab, take a look at the calculation that was running at the time, okay? So the question was the calculation showing the evolution of that second harmonic peak in the spectrum and then also in the shapes of the waves in the phases correctly? I went into the lab, I looked at it, and it was. It was. No adjustable parameters. And I had a feeling that I've only had twice more, and I don't think I deserve to have it twice more. I had a feeling that for the first time in humanity, I was the first person to really, really understand something that was going on in nature that nobody else had ever known before. I'm addicted to it. I live for this. I hope that the younger people here also get to experience this at one time. Not I did this problem, or not I got this result, but I understand something that probably nobody else ever did to the same level. And I just tell you, you strive for it, okay? Because it's like no other feeling. Well, maybe there's a couple of other ones, but I don't want to go into that. Designed a big experiment. Designed the wave staffs. Ended up with anomalous drift in the wave staffs the first time I put them on, like the tops drifted away from the bottoms because I wasn't a very good mechanical engineer. Eventually got it right. Instrumented a whole bunch of, a whole big section of off Black's Beach, a nude beach, I might point out, in just north of Scripps. Ran the experiment for several months. It extended offshore. It extended alongshore, designed these arrays, and basically found out that the theory and the numerics that I had worked and worked extremely well, and I'm not going to bore you with that. I decided to publish it. I'm not much for publishing, as many of you know. I have a really good CV for, like, you know, a 35-year-old. But decided to publish it as one paper in Filtrans, a 41-page tome, because it fit together so well. So John Miles, who was on my committee, said, nah, don't do it. You got 5 papers in there. Hal Peregrine said, yeah, you probably have 4 or 5 papers in there. You're only going to get 1 out of it. And I said, yeah, but Filtrans. And eventually Jerry Witham from Caltech, a fellow of the Royal Society, sponsored the paper, and it came out, and it's definitely the best paper I've ever written in my life. My advice to you is publish more. If you got 4 papers, publish 4 papers, okay? Because then you don't have to be along with your CV going, you really need to read this, it's great. Okay, I'm not going to go over all of the details, but let's just say that this model that I and we came up with works. It is what happens in waves. The fore-aft asymmetry comes from a near resonance that is from a balance of weak dispersion and weak nonlinearity. Okay, so let's see. What else did I want to say here? I'm running out of time until 1 o'clock, but you're not running out of time. I'm not running out of time to talk. Okay, let's put it that way. So I had to find an actual paying job. Okay? And there we go to the next one. So again, against all the advice of smarter people, I decided to take a job as a junior professor at the Marine Sciences Research Center in Stony Brook. Okay? At that point, we were married, and I wanted, for reasons that I don't understand, I wanted to get away from the West Coast. Went to Stony Brook. It didn't work out. Okay, fine. As soon as I got there, I started getting letters from people going, would you like to come here? Would you like to come here? et cetera, getting a bunch of letters and communications from my friend Dudley Chelton, who was at the Jet Propulsion Lab. And so I actually decided to take a risk. Okay, we talked before about the roller coasters and everything. I found this on the web. Geez, these people are crazy. Okay, but the deal was they were trying to set up a satellite oceanography department or group at the Jet Propulsion Lab. Because we had CSAT that NASA had flown in 1979. It lasted for like 90 days, had a bunch of ocean observing microwave instruments on it for the first time. That's that thing there. But nobody knew how to analyze the data from anything but the synthetic aperture radar. It had an altimeter. It had a multi-channel microwave radiometer. It had a scatterometer on it. And Stan Wilson in the upper left and Wilfred Townsend in the upper right were the program managers, and they decided to put together a satellite oceanography group at JPL to at least be able to get to the bottom of what this data had and how were we going to measure the ocean. And before I got there, there was Lee Fu in the lower left-hand corner, Tim Liu, Dudley Chelton, my friend, who you will see that I followed around for my entire career, and somewhat part-time Mark Abbott. All of these people were there. I came in early 1982. We were the satellite oceanography group. There is no such thing as a ship oceanography group. I don't quite understand where satellite comes from. But all of these people are incredibly, they all took the risk on their career to go to JPL and do satellite oceanography, try to figure out how to observe the oceans from space. Lee is an elected member of the National Academy of Engineering. Tim has all kinds of awards. Dudley was the first ocean distinguished professor at Oregon State. He left, see, I followed him. He went from Scripps to JPL. I followed him. He went from JPL to Oregon State. I followed him. And he's won a bazillion awards. And of course, Mark is the president and director of Woodsall Oceanographic Institution right now after having been dean at Oregon State. So it was a really fun group of people to work with. And you know, we were attacking the problem of how do you understand what goes on in the ocean with the coverage that you need. Because if you're in a ship, it doesn't work. By the way, that's Roger Revelle again. I gave the Revelle Memorial Lecture in 2008 or something like that. And so I have a bunch of these slides. So my job here at Scripps was basically scatterometry. Okay? I said that, which is the measurement with microwave, active microwave, of wind speed and wind direction at the surface of the ocean from space. Day and night, clear sky and clouds, it's great. There's a whole story about scatterometry. I don't have very much time to go into it, but suffice it to say that there was a competition when I arrived between Goddard and JPL about which NASA center would go forward with the scatterometer program. Because Langley had built the scatterometer, Bill Grantham and Linwood Jones, that flew on CSAT in 1979. And there was this feeling that if we could only figure out how to analyze the data, there'd be a lot of good information about air-sea interaction, wind-driven currents, and atmospheric forecasting from that. But Langley basically told Stan Wilson to go shove it when Stan asked them to do some jobs for him. And they said, we know how to run the scatterometer program, and we're going to do it. And he said, I'm from headquarters. And they didn't get it. And so he shut them down. Okay? And then they had this competition between Goddard, Milton Hallam's group, and JPL. A guy named Fook Lee, a young radar engineer who for a long time now has been the head of JPL's Mars Exploration Program Office, and I were given the job of winning this line of business for JPL. We were both extraordinarily young, under 30, and neither of us knew a thing about scatterometry. He was a good radar engineer. I was something. Long story short, we put it together. Okay, we won. I'm not sure it was all that hard to win from Goddard, but we basically won. And there's all kinds of stories that that go along with it. We sold NSCAT, which was the first scatterometer, in 1984, I think, to Bert Edelson, who was the AA at the time. And we came back to headquarters and we gave our pitch, and he said, you guys won, but I want you to treat NSCAT in the spirit of a fixed price contract for $72.4 million. And we were going to launch in 86 or 87. That sounded good. Fook and I went out to our car, looked at each other, and burst out laughing, going, what does in the spirit of a fixed price contract mean? Well, we figured it out, $220 million. Okay? And it didn't launch in 87, it launched in 96. Okay? You spend a lot of time working on these things. Okay? But I learned to work in a hierarchical environment for the project work. Okay? It was the first time I had ever done it. And it was different. I also did all the jobs, just like I had done in grad school, just like I had done as an undergraduate. I sat in engineering meetings. I sat in ground system meetings. Fook and I were sort of the leaders of this thing. I sat in budget meetings. I worked view graphs with people and basically did it all. And when the time came, my title was project scientist because they didn't know any other title to give me. But when the time actually came to make calls, like, should we do this in hardware, or should we do this in software, or should we put it off and let the science team do it later on, my voice had weight. Because they knew, everybody around, all the engineers, knew that I was deeply involved. Okay? And so that's another thing to take from this. Okay, long story. NSCAT eventually flew on a Japanese spacecraft. That spacecraft failed after about 10 months. I had already written the proposal for SeaWinds, the next generation scatterometer that was going to fly on the space station, which hadn't flown then, by the way, but also had an appendix for polar orbiting, just in case NOAA didn't come through with their scatterometer. That's a story. So we were building that. NSCAT failed, or the spacecraft failed. The Japanese spacecraft failed. We took the flight spares that we had. We put them together, and we flew QuickScat, which launched in like 1999, really quickly. And then SeaWinds on Adios 2, also on a Japanese spacecraft. And that, by the way, that spacecraft also failed almost to the day, the same mission length that Adios 1 had. So we know failures too. And there's a lot more to say about my time there. I guess the only other joke that I'll tell you is I always wanted Fook Lee and Li Fu to write a paper together. Okay? Li Fu and vice versa. Okay? So, oh yeah, I should actually talk about, so I left JPL basically because we had kids. We wanted the kids to go to public school. Public schools in Pasadena were not good, even though we loved where we lived and we loved our house and everything like that. Had job offers from Scripps, from Woods Hole. Shoshana had already picked out house at Woods Hole. Stan Wilson, my mentor, as you remember, said, why don't you look at Oregon State? Dudley had already gone up to Oregon State. Mark had gone up to Oregon State. We looked at Oregon State and we decided, you know what? Sure, it's hard to park a Conestoga wagon parallel, but it's probably the best place to bring up kids. And we went there, and I did everything, quote, unquote, except publish, publish a lot, at Oregon State. And the professor thing, the project science stuff, still, because none of these things had launched, okay? And we did, serving on academy committees, university stuff, university service, everything like that. I became associate dean under Mark. I was the dean of space research. You wanted more space for your lab? Come to Mike. Okay, and I got stuff done. But there I was learning about how to operate in a pseudo-hierarchical organization. Bunch of academics, all soft money academics. Full professors only got 40% of our salary. But yet in a university, in an administrative job. Okay, so I was all set up when I got a call in 2006, probably early 2006, from Jack Kay, going, you know anybody who wants to come to headquarters to run the Earth Science Division? Because Mary Cleve wants to know. Both of our kids were on the East Coast, part of the deal with going to Corvallis, which is quite a diverse community. You got white people with blue eyes, you got white people with brown eyes, all kinds of different hair colors, the whole thing. There's 50,000. Now there's 50,000. There was about 35,000 people there. I know it's 50,000 now because at 50,000 you get a big box store, Home Depot. And we didn't quite have it then. And the deal was the kids would go to the East Coast and get the hell out of Corvallis to really learn what life was after they graduated high school. Sarah went to Haverford, our daughter. Daniel went to Amherst. I talked to you about him before. So they were both going there, and I said, yeah, I'll come to headquarters. And Shoshana and I figured we'd do it for about 2 years, go someplace where we didn't have to drive 100 miles to go out to eat. Does anybody know what this is? Pardon me? You got it. Okay? It's Botticelli's map of Dante's Inferno. I don't know why I chose that for headquarters. Okay? But to return, so I told you the story about my mom. I'll tell you the story about my dad now. He died actually on my birthday in 2002. And it's probably good for me in some strange way that he did. He was fiercely independent. He had his own business. People would ask him, how many people work at Chronolog? He'd say, about half. And he had two things to say about working in the government. The first one was, civil servants are generally neither. And the second one was, if you're going to be a bureaucrat, you got to say no. Dad, why? He said, because if you always say yes, soon people will say, why do we need him around? Everything we bring him, he says yes. Get rid of him. So you say no as a civil servant. Okay. So I had sort of envisioned headquarters as, being the watchful guardians of the taxpayers' money. Any little mouse that moves, we come and get it. Of course, turned out to be more like this, like, holy moly, in a second it's going to be cold, and I'm going to be down there. Okay? Had a bunch of objectives that I don't want to talk to you too much about, but they were real, clear, written objectives when I got to headquarters. To launch the legacy missions, to ensure balance in our program, and I think we've been pretty successful at that. To use the decadal survey to build community cohesion and consensus, to develop an executable program, to actually do the program, and to demonstrate that it's okay to compromise. Let me go back very briefly to Oregon State for a second. And I thank all of you for tolerating me here. One of the things that I did just before I became associate dean was we had a previous dean who said, you can have one hire for the entire College of Oceanic and Atmospheric Sciences as long as all the discipline groups will agree. Well, I, with a buddy, Alan Mix, basically put together, not basically, we put together an economic and demographic model of the college with all kinds of historical rates of people leaving and all that sort of stuff. And we proved, and how much they brought in grants, all anonymized. And we proved that really what we wanted to do and what we could do in the college, and it would make the university money and it would make the college money, was to not hire one person, but to actually hire 4 people each in 4 years at various ages and levels and everything. Presented this to the dean. By that time, the old dean was gone. We had an interim dean. He liked it, said, why don't you present it to the university president? Did that. And he said, why don't you do this for the whole university? And I said, not if you don't pay me. But the deal here was that 16 hires in 4 years. Everybody wanted to be number 1 because they didn't think that that we'd actually get to number 2. I dug my heels in and said, we are going to do this. And we're going to hire number 1, 2, 3, 4, and on and on. And by sticking to it over years, by about the end of the second year, we had discipline groups going, could we trade down because we're going to have good people coming out for a position 2 years, but we're up next year. So the deal is that if you stick to your commitments, okay, it's really important and it builds community. Among the hires, by the way, was a young woman named Kelly Benoit Bird, who actually in about 2010 or so, or 9, became a MacArthur Fellow, one of the Genius Grants. So that's what we wanted to do at headquarters in the field, and also to work closely with our stakeholders, build collaborations. Okay, indulge me for another 5 minutes. Good? Okay, thanks. So this is the geriatric blathering part of the talk. Okay? First of all, and this is for the young people. I was told there would be a lot of young people here. Apparently Goddard's definition of young must be like not chronologically young, but young at heart. Okay? And I feel really good about all of your people's self-images. But learn your profession and learn all parts of it. Okay? Even if you're going to be the PI, learn how to do all the other things. Learn how to program. Learn how to take barnacles off of current meters, and then go off and do it. You will get so much free help, and you will earn so much respect during your career. And that has certainly done a lot for me. Don't lose your focus on substantial accomplishments. And accomplishments are not, I worked on this. Accomplishments are, I did what I said I was going to do, or I learned something new, and now we can do something else. Okay? And in a hierarchical organization, sort of like NASA kind of is, don't leave organizational problems in your wake. If you want to actually do substantial accomplishments, it's going to take time. I had somebody, when I first became SES, you go to these seminars where people who have been SES for a longer time tell you about what to do and how they did it. I had somebody actually, and you would know this person if I identified him or her, but I won't. This person had like, 4 jobs in the last 7 years, each one increasing in the hierarchy. And I said, what's the story? And this person said, if you stay in the same job too long, you find yourself fixing your own messes. I'm not making this up, okay? Give honest assessments, okay? You're smart, you've got credibility. People actually want to know what you think. The job is not to figure out what they think and tell them it. Okay, at other agencies sometimes, I once had somebody describe another agency that starts with N and ends in A, but there's other letters in between besides S and A. Anyway, this person described it as, what interests my boss fascinates me. Okay, that's not what we're looking for. You're not doing your best job. If you think something is right, say it's right. If you think it's wrong, say it's wrong. And once the decision is made, either go with the decision, or you put your badge on the table, or you look for something else to do. You don't litigate forever. But don't just try to figure out what answer people are looking for, because you're not helping by doing that. Okay? And embrace peer review. Competition, I am convinced, is the way to stay sharp. At Oregon State, we were soft money. Everybody was writing proposals all the time, okay? And we were writing like 5 proposals per PI, and we were scoring on 2 of them. Good ones would score on 2.5. Bad ones would score on 1. But we stayed sharp, okay? Even if you have the best group right now, 13 years from now, if you're just being paid to keep doing the same thing, and you have little incentive, and you frankly won't. It's human nature. Get the new ideas in that you'll need to stay sharp. Now, I know that this is blasphemy among many people. Just think ISFM. But also in this competition and in these peer reviews and everything, collaborations give you a tremendous step up. So it's not a competition you against the entire rest of the world. It's a competition of you and your cohort, maybe from different institutions, God forbid, different centers, or something like that, that really can score the best proposals and the best work, and will do the best work. And finally, for those of you who aren't art lovers, and to return to the theme of oceanography, the Phillips is having a tremendous exhibition right now. It's really, really good. Centered around their one Renoir, which is the magisterial luncheon of the boating party, which if you haven't seen it, you really should. Phillips is downtown. And it turns out that Renoir actually said, one must from time to time attempt things that are beyond one's capacity. Don't play it safe. Okay, and he goes on, you know, you can be both a teacher and an artist, and that may seem like it's an undertaking that's beyond your capacity or anybody's capacity. That's all right. Okay, from tremendous effort, tremendous things sometimes emerge. Give it a shot. Okay, do it. And so with that, I've taken, just like headquarters usually does, 30% more time than had been allocated. This is actually a panorama. So this is almost 180 degrees of beach off the east coast of South America at a place called Bahia Bustamante, about 45 degrees south, where Shoshana and I were. Yes, it was really a double rainbow, and you could see both ends. When I got to this end, it said the money was at the other end. Never quite could do it. Thanks very much for tolerating me. I hope this has been useful.
I know we're out of time, but I will allow 1 or 2 comments, quick ones.
What do you see ahead for Earth science?
I'm pretty optimistic, okay? Because of the work that we have done, because of the work that you do, we have credibility. We've done what we said we were going to do. You've done what you've said you're going to do. What we're doing is not only challenging and not only interesting, but it's also important, okay? And people recognize that throughout the administration, this one and previous ones, throughout the Congress, in many different areas, because really we have the ability and we are demonstrating the ability to improve the lives of everybody on this planet. And that is recognized. So, you know, is it going to be living the dream? Probably not. Do I feel like there's an existential threat on the horizon? Actually, I don't. Okay. At the moment, and I've been telling this to people since the election, we have a budget, which is actually at quite a high level. It's at the FY16 level right now in the continuing resolution. We have a budget, we got a plan, and nobody has told us don't spend the money on the plan. We can either go, oh man, we're so depressed we don't want to work, and undercut our own passion and our own arguments, or we can do what they said to do, which is spend this money on this plan, build a bunch of accomplishments, and then see what happens when we get to the end.
Slightly more existential, but if you could do it all over again, do it the same way, knowing you end up in headquarters?
No, that's interesting. Sorry, what did you say at the end? Because I was already thinking of my answer. Oh, yeah, well. If we had the headquarters thing over to do again, Shoshana would not let me do it. Okay, she pretty much despises DC and has more or less from day one, which day one, by the way, was our 25th wedding anniversary. She had had plans for Cinque Terre in Europe and all this sort of stuff. Instead, we had a bunch of boxes, and it pretty much went downhill from there. Probably not, but it has been a fascinating experience. At a place like headquarters, if you know how to work inside a hierarchical organization, but you know the value of accomplishment and credibility, and you're willing to work, kind of like I had spent my whole career learning, you can do amazing things. Not that I did amazing things. You guys did some amazing things when I happened to be around. But you can harness huge power, not power to demand, but huge resources to get stuff done, far more than you could do individually. And I'm fascinated by that. But I'll tell you, if I had the whole thing to do again, I would have published more. I never noticed that my career personally was actually held back, but I have never felt adequate, personally. Okay? I got papers, I got calculations that have been done. I have papers that were accepted pending revision where I never sent in the revision. I mean, this is the stupidest thing you've ever heard. Okay? I got like 3 of them. Because I was off on something else at that point. And then people go, did you ever publish this? And I have to go, no. So publish what you do. It really is the end of the scientific process. And you haven't completed if you don't get to that. And do as I say, not as I did.
Okay, so with that, let's thank Mike one more.